Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 6.7 entitled Solving Absolute Value Inequalities. And today we're going to solve absolute value inequalities and then graph their solution on a number line. Remember, anytime you're dealing with an inequality, you have to graph it on a number line. And in the previous section, we talked about absolute value equations. Now we're going to talk about an absolute value inequality. So that's just an inequality in which the variable is contained inside the absolute value bars. So it might look like the absolute value of x is less than 3. So instead of an equal sign, there's an inequality sign. You could have the absolute value of y is greater than or equal to -4. Okay. Oh, +4. Okay. Now, the trick with identifying how to solve an absolute value inequality is to identify the sign, the less than and the greater than, because they have meaning when we're setting up our problems, our two equations to solve. Okay? The less than sign is going to mean that you have an and compound inequality. Okay, so that's kind of like less than is and greater than is going to be an or graph. So when we're solving our inequalities, we're going to set up two equations. First, you have to get the absolute value by itself, just like we did in the previous section of notes. Then you're going to set up your two inequalities, kind of like we set up two equations before. Now, when you set up the first inequality, it looks very similar to the original problem, but for the second one, you're going to flip the inequality sign and you're going to make the solution negative. So the number that it's equal to, you're going to make that number negative. Because we still have to have two cases. We have to deal with a positive and a negative value that we could put inside those absolute value bars. And then when we're solving our two inequalities, at the end we'll write either and or in our answer. Remember, for the ors, we actually write the word. The ands, we have a special way to write the and compound inequalities, where they're all smushed together like a sandwich. And then we're going to graph our solution on the number line. So we're basically going to have an and graph or an or graph when we get done. Now, here's the thing. You can still get a no solution. So you could have no solution for an answer if the graph that you end up graphing doesn't match the actual answer. Okay? So if you end up graphing an or graph and you were supposed to have an and graph, that would be a no solution. Or if you were supposed to graph an and graph and it ends up looking like an or graph, that's a no solution. You can have a special case too where the whole number line is shaded. That would be all real numbers. Okay, so we have one example and it has 5 parts to it. And this first one in part A, when we solve this absolute value inequality, it's again meant to be a nice basic one. And when we graph it on the number line, we'll be able to see that our solution matches our answer. But again, sometimes students get a little tripped up with this because there's just the x. There's nothing else with it. Like in part B, we have a -4. Part C, we have a 2x. Part D, we have the 2x plus 5. So there's more to undo. So sometimes when students see this with just the x, they are a little hesitant. But really, we just need to think, again, what two numbers could I put in there inside those absolute value bars that would give me an absolute value of 11? Well, that would be 11 and a -11. Okay? So when I set up my two equations, I'm going to have x is greater than or equal to 11. and then I'm going to have x. Now for my second case, I'm going to flip the sign and make the number negative. So that's where I get my negative 11 in. Now the other thing I have to do is after I set up my two cases, I have to ask myself, is this an AND graph or an OR graph? And we look at the sign for that. This is originally a greater or than sign, so I'm going to write or in between my two expressions. Now this is all I have to do for this one. I just have to write the compound inequality because I don't have to isolate the x. It's already by itself. So this is my answer for part A. But I do have to graph it. So I'm going to have negative 11, and then 0, then 11. Now on the negative 11, I want a closed circle, and I want everything to be shaded less than, so that's to the left. For the positive 11, again, I want a closed circle, but I want to shade everything to the right, because that's where all the greater than 11 stuff is. And my graph looks like an OR graph. My answer said I was supposed to have an OR compound inequality, so it looks like we did that one successfully. Okay, now part B, we're still going to set up our two cases, our two equations, and then we'll have a little more to do to get the x by itself. So again, what value, if you substituted it in here, would get you an absolute value of 3? That would be either a 3 or a negative 3. So I'm going to have x minus 4 less than or equal to 3, just like the original problem looks, except I took out those absolute value bars, basically. Now my other equation is going to have x minus 4, and then I flip the sign, and I make the number negative. So there I have my 3 and my negative 3. And my sign was originally a less than, so I'm going to have and. Less than is and. So this one, when I get done and I get my answers, I'm going to have to rewrite it as a compound inequality for an and compound inequality. So as I'm solving, I'm going to add the 4, and I'll get x is less than or equal to 7. Add the 4 again. I'm going to get a different answer. X is greater than or equal to positive 1. So my solution has to be between 1 and 7. So how we write that is like this. 1 less than or equal to x less than or equal to 7. So just like we saw the compound and inequalities in the previous notes, the smaller number goes on the left, the larger number goes on the right. The signs both have to be less thans. And here it was a less than or equal to and a greater than or equal to. So we do kind of flip this one around, but we still have to keep those equal tos. And then we have to make our graph. So 1, maybe 4 is in the middle, and then 7. So I'm going to have a closed circle on 1, closed circle on 7, and I'm going to shade everything above the 1 and everything below the 7. So you can see where that shading would overlap. That's going to be my and compound inequality. Okay, for part C, I'm going to set up my two cases again. And the two values that I could put in here that would give me an absolute value of 8, that's going to be 8 and negative 8. So my first equation is going to just be equal to 8, or basically look like the original inequality, just without those absolute value bars. And then I'll have my 2x and flip the sign and make the 8 negative. So I have my 8 and my negative 8. And then I have to look at my original sign. It's a greater or than, so I know this is going to be an or compound inequality. And then I divide both sides by 2. So I have x is greater than 4, or x is less than negative 4. So with the ors, these are nice because you don't have to smush the answer together like we did for part B, where we had to rewrite it. We just want to make sure that our graph is really an or graph. So I've got negative 4 and 4. 0 can go in the middle. So I wanted everything above 4, so open circle and shade to the right. Everything less than negative 4, so again, open circle, shade to the left. Okay, so that looks like an oar graph. Looks like the oars in a boat. Okay. For part D, same process for setting up our equations. We're going to have one set equal to 7 and one set equal to negative 7. So 2x plus 5 less than or equal to 7. And then 2x plus 5. I'm going to flip the sign and make the number negative. And then this is a less than, so that's an and graph. So when I get done, I'm going to have an and compound inequality. I'm going to have to rewrite my answer in. So when I solve the inequality on the left, I'll have 2x less than or equal to 2. And I'm going to divide. So x is less than or equal to 1. And you can bring the and down if you want. I'm going to subtract the 5 over here as well. 2x is greater than or equal to negative 12. I divide by 2. So again, I'm doing the same steps, but I'm going to get a different answer. I get negative 6. Now I can't leave my answer written like that. It's not proper mathematical form. So I'm going to rewrite this. I'm going to put the negative 6 first because it's smaller. The x goes in the middle and the bigger number goes on the right. And then I have to have less thans. And both of these inequalities have equal to's. So I'll make them less than or equal to and less than or equal to. There's my solution. And then I'm going to put these numbers on a number line. Negative 2 might be in between them. And I'm going to have solid circles on both. And since it's an and, I'm going to shade in the middle. Okay, don't forget about part E over here. Now this one is a little trickier because it has this plus 5 outside the absolute values. I'm sorry, minus 5. So I have to add 5 to get it out of there first before I can even set up my two cases. Wrote the wrong number there. Okay. So 3x minus 2 greater than or equal to 10. So now that I have it all by itself, the absolute value bars, now that they're all by themselves, they don't have anything outside of them, then I can set up my two cases. So I'm going to have to set this equal to 10 and negative 10. So 3x minus 2 greater than or equal to 10. And then 3x minus 2, flip the sign, make the number negative, less than or equal to negative 10. Now originally I had a greater than, so this will be an or graph. So then I'm going to add the 2. 3x is greater than or equal to 12. And divide by 3. So x is going to be greater than or equal to 4. Or, and then same steps, I'm going to add the 2. 3x is less than or equal to negative 8/3. Then I have to, oops, haha, I'm doing 2 steps in one there. Sorry, I was thinking ahead. Okay, when I subtract, I get negative 8. Then I have to divide by 3, so I get x is less than or equal to negative 8/3. So again, since it's an or, that's my solution. I don't have to rewrite it, but I do have to graph it. Then I need 4, probably need 0. Then I have to ask myself, where is negative 8/3? Okay, this is really negative 2 and 2/3. So I'd have to have negative 2 and negative 3. And then negative 2 and 2/3 might be right about there. Negative 8/3. So I want a closed circle on the negative 8/3 and then a closed circle on the 4. I want everything greater than 4, okay? Everything less than negative 8/3 looks good. Looks like the oars on a boat. They're going in opposite directions. Okay, so that problem really has a lot of information in it. That's probably the best example for a thorough process where you're using all the steps. especially this one that we began with, where you have to get the absolute value all by itself first. You have to get rid of the 5. Don't forget to do that. Then you can set up your 2 cases. So a lot of times students forget to add the 5 over first, and a lot of times students forget to set up the second case. But just think, when you have 2 absolute value bars, you need 2 solutions. And here are your homework problems to practice these concepts. Definitely show your work. Make sure you do your graphs. And if you have any questions, come on in and see me before school.